With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Student, the question is the maximum line of sight distance dm between two antennas having heights ht and hr above the earth is. Students, first of all discuss about the line of sight distance. Students, we can draw, this is earth surface, we can write this is earth surface, and there is a antenna which is, we can draw this is transmitting antenna and this is receiver antenna. So the height of this antenna is given HR and height of this antenna is HT. So the signal, actually this is the space wave propagation, we can write that this is space wave propagation, and students, this is used to broadcasting in television. So if the signal is moving from this point to this point, then this is a tangent point on Earth's surface. So the distance from transmitter to this point, tangent point, is dt, and similarly the distance from this point to receiver is dr, and we can write, we will write this capital R as in this question given. So we can write it dr and d capital R. So the distance between transmitter to receiver will be equal to dm, which is the line of sight distance. We can write that dm is line of sight distance. So students, now we have to calculate the value of dm. So we can calculate the value of dm. Suppose we can draw the diagram like this. Suppose this is earth surface, and there is an antenna at this surface. This is antenna at this surface, and suppose this point is P and this is Q. So it is clear that the signal will go from this point Q to this surface like this, and similarly as from this, and we have taken the height of this antenna, which is h. So students, it is clear from this figure, due to the curvature of earth, the signal will not go beyond this point. Suppose this is S and this is T, these are the tangent point, and we can calculate the value of, this is the center of earth, this is the center of earth, and the radius is capital R. So we can draw line like this. So we can calculate the value of d. D will be the distance from this point to this point, and from this point to this point. We can write this is D and this is D, and this point is O, and this is antenna, as we can draw like this. So students, as it is clear that this angle is 90 degree and this is also 90 degree because it is tangent. So students, we can write in triangle SQP, which is right angle triangle. So we can write at that means SQ square will be equal to SP square plus PQ square. That is SQ square is equal to SP square plus QP square, and SP square, here SP is equal to D, so it will be equal to D square, and PQ, we have taken PQ is H, so it will be equal to H square. So suppose this is equation 1. Now in triangle OSQ, this is also right angle triangle, so we can write OQ square, that is hypotenuse square, is equal to OS square plus SQ square. OS square plus SQ square, and OS is R. So we can put the values. It will be equal to R plus H whole square is equal to OS is R square, and SQ square we have calculated, it will be equal to D square plus H square. So we can simplify this equation. It will be equal to R square plus 2RH plus H square will be equal to R square plus D square plus H square. So we can cancel the terms like this. So it is clear that D square will be equal to 2RH, and we can write D will be equal to square root 2RH. So students, here for dt we can write it will be equal to, we can write for dt it will be equal to square root 2RHT, and for dr it will be equal to square root 2RHR. So it is clear that dm will be equal to dt plus dr. So we can write dm will be equal to dt plus dr. So we can put the value, it will be equal to 2RHT plus square root 2RHR. This is capital R. So the answer of this question is option D. Thank you students.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.